I want you to look carefully at the periodic table, memorize it, and memorize it extremely, extremely well. All right?
Doctor, I cannot hear your voice.
Now I'm going to talk. Okay. All right. Bismillah ar-Rahman ar-Rahim. Alhamdulillah wa sallallahu ala Rasulullah. Yes. As I said, first thing, I want you to make a copy of the periodic table and make it available with you all the time, in every lecture. Why? Because we will always refer to it. And I want you to use my periodic table. Why? First, there are many reasons. The first reason is you are given the periodic table. This is the periodic table that we are using. And here in any element, you know what's the atomic number, which is, for example, here 28 for nickel. And you see the mass, which we are going to use, the atomic mass, okay, which is in this case 58.69. And also you're given here all the these constants that we're going to use in the course. And I want you to know to keep these constants. Don't memorize the numbers, but know what are these constants. For example, the most important thing we're going to see here today is Planck's constant. It's given to you, even though I want you to memorize it, but it's given to you what's the Planck's constant. Okay, keep this periodic table with you, even if you are in the discussion, because during the discussion, I want to, today we are going to use the periodic table a lot to measure the mass of the atom and so on and so forth. All right, I hope this is clear. Good. Okay, now we'll start chapter 3. Chapter 3, what's the title of this chapter 3? It's called stoichiometry. Stoichiometry. What's the meaning of stoichiometry? Stoichiometry means calculation. All right, it means calculation.
Doctor?
Yes.
Could you record?
It's recording, isn't it? Yes.
Yes, it's recording.
Yeah. Okay. All right. Good. Stoichiometry. Stoichiometry means calculation. So when we say stoichiometry in chemistry, we mean things related to calculation and the ratio of combination of compounds. Good. All right. And to start with, we're going to determine, as I said at the beginning, you should know by now very, very well, what's the mass of one proton. Yes.
1 AMU. 1 AMU.
1
AMU. You have to keep this in mind. What's the mass of one neutron? 1 AMU. What's the mass of electron?
0.
Negligible. It's not 0, but negligible. Negligible. All right? Negligible. Good. And that's why if I have hydrogen 1 and 1, what's the mass of this hydrogen? How many protons? Hydrogen?
1 AMU. 1 A.
How many protons?
1.
How many neutrons?
0.
0. And the mass is 1 AMU. Exactly. How about this hydrogen?
2 AMU.
There is one proton, one proton plus 1 neutron. And that's why it is 2 AMU. How about this hydrogen? 1 and 3. There is 1 proton plus 2 neutrons. So we know that this is the mass of 1 proton, this is the mass of 1 neutron. The total is, the mass for this one is 3 AMU. Very good. But look at the periodic table. We'll go back to the periodic table. Good. What's the mass? See, and here, what's this?
Atomic number.
This is the atomic number. Okay, what's this number?
Mass
Average
number.
of mass number.
No, it's not mass number.
Atomic mass.
Yes, atomic mass, which is the average of the atomic numbers. So, again, I repeat one more time. Here, when we say 1 AMU, 2 AMU, 3 AMU, these are the mass number. But if you look at the periodic table, you will find that hydrogen mass is 1.008 AMU. Okay, one hydrogen atom. The mass is 1.008 AMU, which is the average of the atomic mass of the isotopes. These are isotopes, and this is called now atomic mass. Is this clear? Atomic mass. I want you to memorize all of these and keep it in mind. We took this last chapter. This is atomic number. What's the atomic number?
Proton.
Number of protons. What's the atomic mass or atomic number? Mass number. Sorry, mass number.
Mass of the protons with the neutrons.
Number of protons plus
Neutrons.
neutrons. Good. What's the atomic mass?
The
Yes.
average
Mass of isotopes. You have to keep this also in mind. Clear? Very good. Now, if I want mass, this is the mass of hydrogen atom. How about if I have H2O? Then what's the mass of H2O? H2O consists of 2 hydrogen atoms and 1 oxygen atom. So what's the mass of atomic mass? Now, not atomic mass, but we call it formula mass, which is the mass of not now atom, but a compound, a whole compound. You should go to the periodic table. And what's the mass of hydrogen? Hydrogen is 1.008 AMU, which is the average atomic mass. What's the mass of oxygen? It is, look here, what is it?
16.
0 AMU. So what will be the mass of water? It will be 2 hydrogen, so it is 2 times 1.008 plus 1 times 16.000. The total mass of H2O, formula mass of H2O will be 18.016. Can you do it? All right. Okay, very good. Let's do very quickly do this compound H or NH3. NH3. Again, how can I find the formula for mass for NH3? Very quickly, I should go back to here and I'll find that nitrogen is 14.01, and the hydrogen, I have it already here. So very quickly, do it in your calculator. What's the mass of NH3? NH3.
17.034.
17.034 AMU. Exactly. I want to stress also that the unit that we're using here is AMU. AMU. Very important. Why? Because I'm saying what's the mass, formula mass for the molecule. It's for one molecule only, one water molecule, one molecule of water or NH3 or whatever. Okay, good. Keep this in mind. Very good. Very quickly, tell me what's the mass of this compound, C3H8. You need the periodic table. See, I'm not going to bring the periodic table now, but let me help you now. Carbon is 12.01. Hydrogen is 1.008. Oxygen is 16.00. What else? Nitrogen is 14.01. Keep this in mind. But for example, lithium, I don't know what's lithium. I have to go to lithium is 6.94. Okay, go ahead. Solve A very quickly.
44.094.
44.094.
094.
What's the unit?
AMU.
AMU. AMU. Don't forget formula mass for one molecule, and the unit is AMU. AMU. Okay. How about lithium hydroxide? Very quickly.
32.949.
32.949 AMU.
23, I mean. I'm sorry.
23.949. Let's see. Lithium 7 plus 16, 23. Yes, it must be 23. Yes. Okay, good. Okay, how about barium C2H3O2O? Okay, we need to find the mass of barium because I have everything here except barium. So I will go and find what's the mass of barium. Barium is here, which is it 137? Yes. It is
137.32.
32. I don't know. I can't see it very well.
328 without rounding.
Without rounding, okay. 328, I believe you. 328. Keep this in your numbers now. Very good. 137,328. So what's the mass of this one?
255.
Okay, very quickly. Calculate it.
$255.47.
418.
2.54 AMU. Very good.
Doctor,
Yes.
number 2 after the brackets, what does that mean?
After this one?
Last one, yes. After O2.
After O2 is 2. This
Yes,
means
to all the brackets.
yes, of course.
How can we calculate it?
You have one barium. How many carbon?
4.
2 carbon.
4 carbon.
Oh.
How many hydrogen?
6 hydrogen.
6 hydrogen. How many oxygen?
4.
4 oxygen. You add the mass of these and you should get 255.4. Is this clear? Very good.
Yes.
Now, let me ask you a very simple question. Let's talk about C3H8. I want to know what's the total mass of C3H8? 44.09. All right? AMU. Keep this in mind. I want you to tell me what's the percentage of mass of carbon. What's the percentage of carbon only? Not the whole thing, but what's the percentage of carbon? Go ahead. Tell me what's the percentage of carbon.
36 over 44.
Yes, that's how you do it. You make 36.03 divided by
51%.
44.09 times
100.
100, and this will give you the percentage of carbon. Okay, what's the percentage of hydrogen?
Eight over 44. 8.064.
8.06 divided by 44.09 times 100. And I need an answer. What's the answer here?
For carbon,
18.28.
81.71
81.71.
or 72.
71 or 72?
72, because after one is 9.
81.72. Good. What's the percentage of hydrogen?
18.
18.28.
28. Excellent. 18.28%. Good. What's the total of these two?
100.
It must be 100. Is this clear? All right. Very good. I hope this is clear. And you should do it for everything here. If I ask you to find what's the percentage of lithium hydroxide or barium or carbon or anything, you should take the mass of any element divided by the total element. That's all. Good. All right, we did this already. Let's do it for lithium hydroxide. What's the mass of, what's the atomic mass? Atomic mass of lithium hydroxide. How are you going to do it? You should go and find what's the mass of lithium, which we did. And here, what's the mass?
6.941.
So 6.941, and we know that oxygen is 16.01.00, and hydrogen or carbon is 12.01. All right, good. Find the mass of lithium hydroxide. You will find that it should be 73.87. I want you now to find what's the percentage of lithium, what's the percentage by mass of carbon, what's the percentage of oxygen for each one of them. Go ahead and give me numbers, which is here, it's the mass of lithium times 1, of course, oh, times what? 2 divided by 73.89 times 100. Go ahead, give me numbers.
For
Yes.
lithium, 18.79.
79, very good. Okay, do it for carbon.
16.25.
16.25. And do it for oxygen.
64.96.
6. And now add them all together.
100.
100 must be. Good? I hope so, and you're absolutely right. Now, when we have a chemical equation, this is very important, chemical equation, we have to balance it. How to write and balance chemical equation. When we have a chemical reaction, always in chemical reaction, we can write chemical equation. For any chemical reaction, we write chemical equation in which we have reactants. Reactants in this side goes to what?
Product.
Products. Now, by the law of conservation of mass. What's the law of conservation of mass?
The mass of reactants equal the mass of products.
Must equal the mass of the product. All right. This means any atom that's available here, it must be the same amount available here. That's why we need to balance chemical equation. We need to, this is a chemical equation. When we write it, we must, what is in this side?
Reacting.
Don't forget, this side, these are reactants. And this side are called products. Okay, good. Now, it's not enough to write the chemical equation like this. First, you have to write whatever the reactants and the product. You have to put what is the physical state of the chemical reaction. What do we say here? We say that SO3 combine with H2O to give you H2SO4. This is the reactants again. And this is the product. And we say that this react with SO3 react with H2O to give you the product as H2SO4. But this is not enough. We have also to put the physical state. And I want you to memorize this very well. What's G stands for?
Gas.
Gas.
And L?
Liquid.
Liquid. And S?
Solid.
And AQ?
Aqueous.
Aqueous. What do you mean by aqueous?
محلول.
In water. In water. In H2O. Is this clear? Very good. So what's the reaction here? I want you to read the reaction. You should say that NH3 what? Gas react with what's the name of this compound? We took it in chapter 2. Hydrogen chloride gas. Hydrogen chloride gas to give you. You should know the name of this compound also. We took it in chapter 2. This is a special group. What's the name of this special group?
Ammonium.
Ammonium chloride solid. Ammonium chloride solid. You should know how to say this reaction. And here we say that calcium carbonate solid react to give you, or by itself decompose. We say it decompose to give you calcium oxide and calcium oxide solid plus carbon dioxide gas. Okay, here sulfur solid react with oxygen gas to give you sulfur dioxide gas. SO3 or sulfur trioxide gas react with water liquid to give you H2SO4, which is sulfuric acid from aqueous solution. You should know how to name these compounds. We are still not done also. We should make sure that the number of atoms in reactant is equal to the number of atoms on product. In this last reaction, how many sulfur atoms we have? The total sulfur atoms we have in reactant? One sulfur.
One.
How many oxygen?
4.
4 oxygen. How many hydrogen?
2.
2 hydrogen. And the product, how many sulfur? 1 sulfur. Product. How many oxygen?
4.
And how many hydrogen?
2.
Is it balanced?
Yes.
Balanced. We should make sure that the chemical reaction is balanced. Okay. If we have allotropes, what's the allotropes means? Allotrope, what does it mean?
Same compound.
Two different structure for a compound consisting of one element. Like here, what's this compound consisting of? Graphite is consisting of one atom, which is carbon. What's diamond? Consisting of one atom, which is carbon. But they are two different compounds. This is the pencil that we use, and this is the jewelry. Clear? And both of them react with oxygen to give you CO2 gas. CO2 gas. Allotropes, you have to know what's allotrope. Two different structure, graphite and diamond, for a compound consisting of only one element, or two different compounds in a structure. I should take this. I'll take, sorry, I will take.
So they are not isotopes, doctor?
No, they're not isotope. They are two different compound. Two different compound. One of them is graphite and the other one is diamond, consisting of one element. Both of them is consisting of only one element, like graphite and diamond. Give me example of another allotropes.
Oxygen and ozone.
O2 and O3. Two different compounds. This one is different from this one, and both of them consisting only of oxygen. Good. Good. Okay. I want you to, in your notes now, write this reaction, which is H2 gas plus O2 gas to give you water liquid. Okay. Very quickly balance it at the top here. How many hydrogen we have here? How many hydrogen? 2 hydrogen and 2 oxygen to give you 2 hydrogen and 1 oxygen. Is this balanced?
No.
No.
How can I balance it? I must multiply this by 2 to make this way. I have 2 hydrogen and 4 hydrogen.
Multiply
hydrogen with 2.
2 to make this 4 hydrogen. So I have 4 hydrogen, 2 oxygen, and 4 hydrogen, 2 oxygen. It is balanced now. That's it.
Doctor.
Yes.
The first one, how can we get H2O and we have 2H and 2O and we have the final just one oxygen. Where's gone the second oxygen?
That's why you need to balance it. The other oxygen is here now.
Yes.
That's when it's balanced. So we have 4 hydrogen, 1, 2, 3 hydrogen, and we have 2 oxygen, 1, 2, and in the product we have 1, 2 oxygen, 1, 2, 3, 4 hydrogen. Clear?
Yes.
Okay, good. When we have a whole group like CO3, 2 minus, we can treat it as a group, multi-atom or multi-atomic ion. In balancing, we can use CO3 as a whole group and keep it, always follow it up as a whole group. Okay, very good. Let's do this problem. Let's balance this equation. C4H10 plus O2 to give you CO2 plus H2O. How should you do it? Concentrate with me. Do it for each atom by itself first. So how many carbon do we have in this side?
4.
How many do we have in this side?
1.
Well, the first thing I will do, I will multiply this by 4. Okay? This means I already balanced the carbon. Clear?
Yep.
Now, when I have 4 carbon, then I'll go to the other atom, which is hydrogen. How many hydrogen I have here?
10.
And how many hydrogen do I have here?
2.
Only 2. There is no other hydrogen. What should I do here?
Multiply with 5.
By 5. Now the hydrogen is balanced. Good. What am I left with?
Oxygen.
Oxygen. How many do I have here? In oxygen?
2. 2
How many oxygen
on the left side.
on this side? How many oxygen do I have?
8.
8.
8. And how many I have here?
One.
What?
5.
5. What's the total?
13.
13 in the product. In product, right? Right? How many I have in
Yes.
reactants at this time?
2.
Only 2. How can I balance it?
Multiply by 7.
Multiply by 13 over 2. All right? When you multiply 13 over 2 times 2, what's this equal to?
13.
13, which is already balanced. Good? But we don't like to keep fraction in the chemical equation. So what's the next step? I will
Multiply by
multiply
2 whole equation.
the whole equation by 2. So what will be the total equation at the end? It will be here what? Multiply everything by 2.
2C.
2C4, it's 10.
2. And then 13. And then what's this?
8.
8. And this one?
10.
10. Yes. Now let's go and check everything one more time. How many carbons do we have in this side?
8.
8.
How many carbons do you have in this side?
8.
8. How many hydrogen? I have 2 times 10.
20.
20.
How many on this side?
20.
20. How many oxygen do I have here?
26.
26 on this side. Let's see. 8 times 2 is what?
16.
16.
16. And then times 10 times 1.
10.
What's the total? 26 oxygen. 26 oxygen. So it is balanced. Do you know how to balance things? Now, as I said, this is a trick that you need to do sometimes to balance, just to make sure that everything is okay. Is this clear? Yes.
Many different to balance, or the numbers of coefficient.
What again? Let's go to example. I think I will answer your question in a while. Okay, let's very quickly see. Let's read the question. I'm not going to give you this in an exam. I will tell you, write a balanced equation for aqueous reaction of barium hydroxide. I will give you the name like this, and you should know that barium hydroxide is actually this compound. And then I say aqueous. What do you mean by aqueous?
In water or the state.
And perchloric acid. You know what's perchloric acid? This is perchloric acid. We took it from before and chapter 2, and again aqueous barium hydroxide and perchloric acid to produce barium perchlorate. That's barium perchlorate and water. So in the exam, I will give you the question without the equation, and I want you to write this equation. Is this clear? Good. Now, look at this carefully and balance it very quickly. Go ahead. Do it one by one. First, start with barium.
Barium is okay. Barium is balanced.
1 and 1. So it's balanced. Good. Then go to chlorine. How many chlorines we have? How many in the reactant?
1.
1. How many in product? 2. Okay, 2. a reactant. Yes.
I have to multiply by 2.
multiply by 2.
Divide this by 2. Now the chlorine is multiplied by 2 and it is 2. And on this side we did not multiply by anything, so the chlorine is balanced. Very good. Next, go to hydrogen. How many hydrogen we have here? We have 2 plus 2, 4. And how many we have here?
2.
There's no hydrogen. There's only here. So what is it?
2 multiplied by 2.
Multiplied by 2. Very good. Last thing, so on this side, so hydrogen I have 2 in here, 4 in here, and yeah, 2 and 2, 4. 2 plus 2, which is 4. Very good. 2 plus 2 hydrogen is 4. Last thing is oxygen. What's oxygen?
10.
I have here 2 times here 2 oxygen, and then this side I have 8 oxygen. Total is 10. 10. So in the reactant I have 10. How many in product?
10.
I have 4 times 2 is 8, and 2 is 10. So it is already balanced. Do you know how to balance it? Good.
Teacher. The doctor.
Yes, go ahead.
Usually, should we start on which element?
You keep the oxygen last thing, and hydrogen is the one before the last. So do everything other than hydrogen and oxygen. Hydrogen is the one before the last, and the last thing is oxygen. Okay, go ahead, balance this equation. I'm not going to talk. I want you to do it yourself. As I said, what's the best thing to do? Start with carbon and find how many reactant and how many should have in product, and then after carbon, hydrogen, and after hydrogen, oxygen only.
Carbon we have 4.
4 here.
And the side 1. We should multiply by 4.
Exactly. 4. Now the carbon in product is also 4. Very good. How about hydrogen?
Hydrogen we have 8, so we should multiply it by 4.
8 here. We have only 2 here. I will multiply this by 4. This means 8 hydrogen. Very good. Next.
Oxygen we have 4. Another side we have 5. We have 9.
And 2 and 2, 4.
12. Another side 12.
We have here 8 and 4, 12. So
Multiply by 5.
That's by anything. Don't multiply by 5.
Multiply by 5.
Only multiply this by 5 because it's the only thing that has oxygen. This thing, if you multiply it with anything, you will change the carbon and hydrogen. So multiply this by 5. In this case, we have 12 oxygen in here, and we have 2 plus 5 times 2 is 12. So everything is balanced. You know how to balance things now? Very good. So let's say, how can we read this? How we read this? We say that one molecule of C4H8O2 react with what? Go ahead.
5
molecule of oxygens to make what?
4 molecules.
4 molecules of CO2 and 4 molecules of
water.
Is this clear? I repeat one more time. Whenever you have a chemical reaction, you should say that one molecule of C4H8O2 react with 5 molecules of O2 to give you 4 molecules of CO2 plus 4 molecules of H2O or H2O water. Is this clear? Okay. Now, I will define something extremely important. What? The mole. All right? And the mole is very easy number. The mole, the first definition of the mole is it is Avogadro's number. And this is Avogadro number. You should memorize it, even though I'm going to give it to you in the periodic table. See this number? What's the name of this number? It's called Avogadro's number. Avogadro. We will refer to it as NA. Whenever I write NA, you should, what's this letter means? Avogadro's number. Good. And what is this Avogadro's number? It is 6.022. You don't have to memorize the rest. 6.022 times 10 to the power 23. I want you, whenever I ask you what's Avogadro's number, you should say right away, it's 0.22 times 10 to the power 23 without unit. It's just a number. Right? And as I say, it's available for you. Do you see this number? Oh, not plan. What's this number? Can you see it?
Yes, yes.
It is Avogadro's number. So in the exam, I will give you Avogadro's number, but even if I give it to you, I want you to memorize it. But it's available for you in here. And if you read very clearly, it's not very clear, I know, 0.6.022 times 10 to the power 23 available for you here. Memorize it and keep it in your mind. And keep it in your mind that this is called Avogadro's number. Avogadro's number. Very good. What do I mean by this? If I ask you, I'll go ask you, what is 1 dozen? What are you going to say?
Dozen is 12.
Dozen means what? 12, right? 12. What's the unit?
Just a number.
Just a number. A dozen means 12. A dozen means 12. Whenever so if I have 5 dozen of eggs, dozen eggs. So how many I have total eggs?
60.
60 eggs. So from where did I get the unit?
Because it doesn't of eggs.
Because I said eggs here. But if I say I have 3 dozen oranges, okay, then how many I have here?
36 orange.
6 orange. Okay, very good. If I have 100 dozen of sodium, then how many atoms of sodium do I have?
1,100.
What? 1,000. Oh, 1,200. What?
And
Sodium.
Thousand.
Sodium. Whatever I said. Is this clear? Is this clear? So
yes.
It doesn't have no unit, but if I put anything with unit, then it will take the same unit. Okay, whatever I said about dozen, I will say about a mole. Whenever I say 1 mole, you should understand that this is a number. What's this number? It's 6.02 times 10 to the power 23. And what's a unit? What's a unit here?
Anything.
No unit. No unit. If I say 1 mole, you should say it's 6.022 times 10 to the power 23 without unit. Is this clear? Okay. If I say 1 mole H2, then what is this equal to?
Same.
What? 6.022 times 10 to the power 23, and then I should say what?
H2O.
H2, not O. H2 only. Is this clear? If I say, for example, I have 3 mole Na, then how many Na is there?
3 times the Avogadro number.
3 times
Na.
6.022 times 10 to the power 23 Na. Is this clear? I want to stress one more time. If I say 1 mole and stop, what's this equal to? Avogadro's number. What's a unit?
No unit.
No unit. No unit. If I say 1 mole H2, then I say it's Avogadro's number with unit. Whatever unit I use, I put in the unit here. So I should say here 1 mole of H2 molecule. Here H2 molecule. 1 mole of sodium atoms. I should say sodium atoms, and so on and so forth. So if I have 3 or let's say 5 or 0.5, 0.5 mole H2O, then this is equal to what? .5 times what? 6.422 times 10 to the power 23 what?
H2O.
O molecules. Because this is H2O molecules. Is this clear? I hope this is clear. Very good. So, as I told you in chapter 1, always, whenever you say 1 mole of any object is equal to what? Avogadro's number of what?
The object.
The object.
The same object. We say it here. So we can do it like this. We can do it like this to get rid of numbers. So if I have this object here, I will say 1 mole hydrogen H2 molecules. This is equal to what? 6.02 times 10 to the power 23 H2 molecules. Clear? Very good. Now, if I have 0.2 mole H2 molecule, then how many molecules is this? How many molecules? I should multiply it by what? What should I put at the top and the bottom? I should write here 1 mole of H2 molecule And at the top, show what should I write?
forgot the number.
6.02 times 10 to the power 23. What?
Multiply with 0.2
H2 molecules. And this way, you get rid of this unit with this unit, and you have the answer. Is this clear? So I want you to know how to, because this is equal to this, always keep in mind that I can get rid of any unit by dividing or multiply it by the other unit, like this. Make a fraction like this, and unit conversion here, make what's called unit conversion. Is this clear?
Yes.
Very good. A typical body, our body, contains 30 moles of calcium. So in your body, there are 30 moles of calcium. So what's the information that we have? We have 30 mole calcium. Okay. Determine how many calcium atoms. I know that 1 mole calcium atom, 1 mole calcium atom equal to how many?
Avogadro number. Calcium.
Number times 10 to the power 23 what?
Calcium.
Calcium what? Atom. Calcium atom. Our body consists of 30 calcium atom. 30 mole of calcium atom. How many molecules is this? Which fraction should I use? First or second fraction?
Second.
Second fraction. Get rid of it by saying 1 mole calcium atoms. And here 6.022 times 10 to the power 23 calcium atom. And you have the answer. Is this clear? Yes. Is it easy?
Yes.
Good, this is the solution. Next, B. The number of moles of calcium in a sample containing, determine if we have 1.00 times 10 to the power 20. So we have 1.00 times 10 to the power 20 calcium atoms. How many moles is this? Which fraction?
Divide the second one.
By the Avogadro number.
Which fraction should I use to solve this?
Second one.
The first.
First one.
I have calcium atom here. I want to get rid of calcium atom from here. So I should say 6.022 times 10 to the power 23 calcium atom. And I get rid of this unit with this unit. And at the top I have here 1 mole calcium atom. And I have the answer in calcium atom. The final answer will be calcium atom. You should get rid of units. That's why in the second one, you use this fraction, fraction 2, 1. In the first one in here, we use fraction 2. Is this clear? I hope this is clear, and this is the answer for this one. Good. Next, the other definition for the mole. Still, we have the mole. We define the mole. The first, so we have 2 definitions for the mole. The mole, and usually when we write it in chemistry, we just say MOL without the E. So when you say 1 mole of calcium, for example, 1 mole calcium, what's this equal to? 6.022 times 10 to the power 23 what?
Calcium.
Calcium. You should say the same unit. Calcium atom. Okay? Calcium atom. Same unit. As I said, when we refer to mole, if we write it MOL, that's a mole. Clear? Okay. This is the first definition. So, what's the definition of a mole? A mole is what? A mole.
Avogadro's number.
الجسم
Avogadro's
مكتوب صح.
number. What's the unit? What's the unit?
No unit.
No unit. No unit. A mole is Avogadro's number without unit. Clear? That's the first definition. First definition. We have another definition for the mole. The mole is mass of atom or molecule in gram. The unit is, what is it?
Gram.
Gram. So if I say 1 mole of hydrogen H2, then this is equal to the mass of one hydrogen atom is 1.008. Get it from the periodic table. We got this from the periodic table. Clear? Times 2. Why did they multiply by 2?
Because there is.
We have 2
hydrogen.
H2.
Which is equal to what now? 2.016. And then what's the unit now?
Grams.
Gram H2. Clear? Okay. I want you now to do, keep this in mind. As I said, you will need the periodic table all the time. Hydrogen is 1.008. Oxygen is 16.00. Carbon
12.01.
Don't memorize these numbers, but it's available in the periodic table. But to solve problems now, we will do it now. So if I have 1 mole of H2O, then how many grams is this?
3.
1 mole H2O. I need the full number. Use your calculator to calculate 1 mole of H2O.
18.016.
18.016 gram. What?
H2O.
You have to say the whole thing. Gram H2O. Good. Let's have 1 mole C3H8. Go ahead.
.something.
44.094.
44.094
grams of
and then yes, you put units.
grams
Gram what?
C3H8.
C3H8. You have to put the whole unit. Gram, but here it is equal to gram. So the mole have two definitions: the atomic mass in gram or Avogadro's number. Clear? Now, from this, we can change from one thing to the other very easily. If I have 10 grams of carbon, 10 grams of carbon, how many moles is this? Keep in mind that 1 mole carbon equal to what?
Avogadro number.
No, I want in gram now.
12.01 gram.
0.01
Grams.
12.01. From where you got the 12.01?
Predictable.
Periodic table. Good. 1 mole of carbon equal to 12.01 gram what?
Carbon.
All right. If I have only 10 gram carbon, how many moles this? 10.00 gram carbon.
Divided by 12.01.
Not divide. I want to multiply by fraction. What's the fraction?
1
1 over
carbon over 12.01 gram.
Mole carbon at the top, top, and then the bottom. 12.01 what? Gram carbon. Then the gram carbon will go with the gram carbon and they have the answer. Is this clear? On the other hand, if I have 0.905 mole carbon, how many grams is this?
Times 12.01.
I should get rid of the mole carbon. I want to get rid of mole carbon, so I will put mole carbon here, get rid of this unit with this unit, and I know 1 mole carbon equal to what?
12.01.
What? Gram carbon. And we have the answer. Is this clear? Very good. Let's go even further. Determine the number of water molecules and the hydrogen molecule atoms and oxygen atom in 3.26 gram water. If we have 3.26 gram H2O, then how many moles H2O is this? What should I do?
The denominator 18.1
H2O is equal to what? 18.016 gram H2O. From where you got this 18.016?
Periodic table.
We add the hydrogen, the
molar mass.
Molar mass, exactly. All right, of the whole thing. And then calculate how many moles this. How many moles? Quickly.
0.18.
0.18 mole H2O. Is this clear? You agree?
Yes.
Okay. How many molecules H2O now? How many molecules? Can you change 0.18 mole H2O into number of molecules?
Yes.
Avogadro.
It is mole H2O, so I will put here 1 mole H2O, and what should I put at the top?
Avogadro number.
Exactly, 6.022 times 10 to the power 23, and then what? Molecule, you have to write this, molecule H2O, and you have the answer. Is this clear? See, we change gram into molecules. Give me the answer.
Uh, 1.08.
1.08
multiply with 10 to the power 23.
Power 23. What? Give me unit.
Mole.
Molecule. No, molecule is 2O. You have to be careful with the unit. Molecule is 2O. So we are talking about each molecule. Is this clear? Now let me ask you a very simple question. If I have 1.08 times 10 to the power 23 molecule H2O, how many H atom in this compound? And how many oxygen atom? First, let's start with oxygen. If I have 1.08 times 10 to the power 23 molecule H2O, how many oxygen atom?
1.08 multiplied by 10 to the power 23.
1.08 times 10 to the power 23 oxygen atom. Why? Because each H2O, it has 1 oxygen and 2 hydrogen. So if I have this number of molecules, I have the same number of oxygen. How many hydrogen atom?
Multiplied by 2.
2 times 1.08 times 10 to the power 23. Very good. Okay, last question. B. If we have 7.92 times 10 to the power 19 molecule CO2 molecules, how many? What's the mass? I want to change it to mass. What should I do?
Change it to mole first, then change it to mass.
How can I change it to mole?
Divided by Avogadro.
1 mole CO2 equal to what? 6.022 times 10 to the power 23
CO2 molecule.
2 molecules. Get rid of this unit with this unit and get the answer. What's the answer?
One
1.31
multiplied
10
1.3
minus
multiply by 10 to the power minus
8.
Then 1.3 times 10 to the power minus 8 mole, right? Right?
Minus 4.
I think
minus 4, not minus 8.
Minus 4. Yeah, it looks minus 4 is much better. Yes, of course. I agree. Minus 4. But it's 1.3, right?
Yes.
Yes. And then don't forget,
I
molecule
think
what?
minus 14.
More CO2. More CO2. Now, if I have 1.3 times 10 to the power 4 mole CO2, how can I change it to gram? I know that 1 mole CO2, give me what?
Multiply it by
the mass from the periodic table.
mass.
Go ahead. Carbon is 12.01 and oxygen is 16. Don't forget this. Carbon 12.01 and oxygen is 16.00. So what should I write here?
44.
Gram what? Don't forget to write the whole name.
Gram
CO.
Okay, and give me the answer. Give me the final answer.
Doctor, I think 1.3 multiplied 10 by minus 14.
3.7 multiplied by 10 to the power minus 3.
3.7 times 10 to the power minus 3 gram CO2. Is this clear?
Yes, clear.
Yes.
Yes, these are the answers. And the answer is 5.79 times 10 to the power minus 3. Well, 3, it's 5, not
It's 5, yes, not 3.
This is the correct answer. Can you see here? This is the answer. You should do it this way. That's how I did it. If you noticed, that's how I did it. It's 2 steps. Instead of doing it 2 steps, I did it 1 step here. And this is, we did it for the first one for water, also in 2 steps or in 1 time. I want you to know how to do these things very well. All right, and we'll stop here for the lecture, and I will delay the homework till tomorrow instead of today. All right.